So this is called polar equations of conics, right? And you better pay attention to this because it's kind of neat, I think, but it's also can get a little complicated. So don't write this down. I'm going to bring something up and show you what this says, okay? So what this says is that you can define a conic by its eccentricity, okay? And so an ellipse are, if I put one point at, so all of these polar equations of conics, they all have a focus at the pole, okay? And the pole, I'm going to get my pen out here, okay? My pole is always 0, 0. So there's 0, 0, there's 0, 0. This is 0, 0, okay? There's always one focus, there's always a focus at the pole when I define my polar equation, when I define a conic with a polar equation. With an ellipse, okay, the eccentricity, okay, is always, it's a constant, and it's always a number that's less than 1 and bigger than 0. Okay, and where that number comes from is by taking the distance from any point on the ellipse to this focus and dividing it by the distance from a point on the ellipse to this line, which is called a directrix. So in this definition, the directrix is very important, and you have a directrix with every form of conic. So if you put the pole right here, and this is your ellipse, the directrix is over here on the left side. There's only one directrix of the ellipse. You'll see how this works in a minute after I teach some more. With a parabola, okay, here's the directrix, here's the focus is at the pole, the distance from this point to this point, and the distance from this point to the directrix is always a constant, and if I divide this over this, okay, that number is the eccentricity, and that's always equal to 1. So any place where I take this point and the distance from here to here and the distance from there to there, and I divide this by this, I will always get 1, okay? And so in this case, if I take this distance and divide by this distance, I'll always get a number that is less than it. In the case of a hyperbola, which also has a directrix, okay, if I take the distance from any point on that hyperbola to this focus, and I divide by the distance from that point to a line called the directrix, I will get a constant bigger than 1, okay, and always, and that will be, and that's called the eccentricity in this case, okay. And it doesn't matter which point I pick. So if I pick a point like up here, and I take the distance from here to here, over the distance from here to here, that number will be the same in every single case. And that number is bigger than 1, and that's the eccentricity. And that directrix kind of defines that hyperbola. Oh, you'll see what I mean in a second, okay? So if, going on to the next slide, okay? Back once. You don't have to write everything down, okay? Just because I'm going to explain more on this next slide, okay? It'll help it'll help see what I'm talking about. What does it mean that the focus is at the pole? There's always one focus at 0, 0. Okay, 0, 0 is the pole. Okay, like with this particular parabola or ellipse, there's another focus somewhere over here, right? And with this hyperbola, there's another focus somewhere over here. But one of them is always at 0, 0. Okay? And with the parabola, it only has one focus, right? So that focus is at. Okay, so what's nice about that definition is that you can define every hyperbola, parabola, or ellipse with these two equations, where E is called the eccentricity, okay? E is called the eccentricity, and P This P up here is the that's the value of P, is the distance between the focus, the focus and the directrix. So I kind of have to do some examples to show what they're talking about, okay? But let me just go through this example, and then I have 4 more things that will help clarify this idea, okay? So see how this, identify the conic. So all you're saying, is this a parabola, hyperbola, or an ellipse, okay? That's all they want to know for this one. Is this a parabola, a hyperbola, or an ellipse? So this equation, you want to get this equation to look like one of these equations. Which one does it look more like? 1 or 2? It looks more like this first one, right? How could I get it to look more like this first one? How can I turn this into a 1? Divide by 5. Okay, so I'm going to divide this by 5. But if I divide that by 5, I have to divide this by 5. And I have to divide that by 5. See? Okay, because now I get, what's 15 divided by 5? 3, right? What's 5 divided by 5? 1 plus 3/5 cosine theta is equal to r. Right? So this number right here is what? Right there. I'll give you a hint. I wrote it there. What's 3/5? E, that's the eccentricity. Which of my 3 conic sections has an E value that is between 0 and 1? Which of my 3, look back at your notes that I just gave you. An ellipse, right? Go back a little bit, right? There we go. Eccentricity is between 0 and 1, so it's got to be an ellipse, okay? So that's all they want in this. E is 3/5, which is less than 1 and greater than 0. Therefore, it's an ellipse. Right? So if I put this into my calculator, y equals 15 over 5 plus 3 cosine theta, I would get an ellipse. Okay? And I set up my window appropriately and stuff. Okay? And that particular ellipse, I'll talk about it a little bit more in a second, but this up here is EP. Okay? And so you could actually find the distance where that directrix is located by finding what P is. Okay? So let me just, if I break these 2 equations into 4 equations, which is the next thing I did for you up here, how to find the directrix. Okay? If it looks like this, okay, R equals EP 1 plus E sine theta, then the directrix, all you need to know is that the directrix is parallel to the polar axis, okay, and it's above the pole, okay, above the pole. So what that means is, if I took this one, I gotta make it bigger so we could see this one. So for this particular form of the equation, if I were to graph this, let's put lines on here. Lines on there. Let's put solid lines. Solid lines, solid lines. Okay. So here we go. The directrix is parallel to the polar axis above the pole. So it looks like this. Here the directrix is somewhere over here. Okay? So if this were an ellipse, I always have one focus at the pole, and the directrix is always on the short side of the ellipse. So this particular ellipse is going to look kind of like this. It's going to have one focus at the pole, and it's going to have another focus down there. Okay? Because the directrix is always on the short side, located kind of on the short side of the ellipse for an ellipse. For a hyperbola, if this were a hyperbola, it would look something like this. Here's the directrix going across. Here's the directrix going across. If it's a hyperbola, you still have a focus at the pole, but one branch of the hyperbola is down here, okay? And one branch of the hyperbola would have to be where? If this is one branch of the hyperbola and this is a focus, where's the other focus going to be? Could it be down here? No, it would have to be somewhere up here, right? So if the directrix is up here, your hyperbola looks something like that, okay? If it's a parabola, right? If it were a parabola and it's this scenario, the directrix is parallel to the polar axis above the pole. If it's a parabola, then the focus, you always have a focus at the pole. Whoops, where'd my stuff go? You always have focus at the pole, and it's going to be looking like this. Okay, so it looks kind of like the bottom branch of that hyperbola. You get that? Okay? So the directrix, so this tells you, this form of the equation tells you where the directrix is.
So if the directrix is, if the parabola goes upwards,
Then the directrix would be down here.
Okay.
Okay, I'm going to show you. Okay, so then for this one, okay, E minus. Here the directrix is directrix is parallel to polar axis below the pole. Okay, below pole. So if I were graphing this real quick, here one focus is always going to be there, right? So if it's ellipse, the ellipse is going to look something like this, okay? If it is a hyperbola and the directrix is going to be down here, one focus is always at the pole, okay? So it's going to be looking like this here. And it's the other focus has got to be somewhere down here, okay? Because if there's a focus, the directrix for a hyperbola is always somewhere in between those 2 points. It's not exactly in the middle, it's in between. And then if it were a parabola, that would be a right side up parabola with one focus at 0, 0, and it would look something like this, okay? Do you understand? Hello? Questions so far? Okay. If it is cosine, guess what is going to happen? Which way do you think my graphs are going to go sideways? Okay. So if it's a cosine, then the directrix is perpendicular to the polar axis. And in this case, since it's plus, to the right. Okay? So for this one, I'm going to go kind of quick. Okay? If it is ellipse, okay, the directrix is somewhere over here. One focus is at the pole, and this ellipse is going to go this way. Do you guys understand why it's going this way, not the other way? Because the directrix for a hyperbola is, for an ellipse is on the short side for the ellipse, okay? If it's a hyperbola, it's going to be going, you're going to have a focus here, you're going to have a directrix here. One branch of the hyperbola is going to be going like this, and one branch of the hyperbola is going to be going like this with another focus. If it's a parabola, is this going to be a right-facing parabola or a left-facing parabola? Right or left? If the directrix is here and the focus is here, where's my parabola? It's going to open this way. Very good, sir. It's going to open now. Okay? And for this case, I'm just going to draw it. Okay? The directrix is over here. Focus is over here. You're going to have an ellipse going this way. Okay? You're going to have a hyperbola. Directrix is over here. one focus is over here, so it's going to be going this way, and then if it's a parabola, it's going to open to the right. Okay, so it'll be going like this, dot here, and boom. All right, you understand what these four graphs tell you? So cosine the directrix is perpendicular, sine the directrix is parallel, plus above, minus below, plus to the right, minus to the left. Yeah? You need to stand up and sit down a few times? No. You want to know the fact of the day? No. Yes, you do. It might help you wake up. How did the cappuccino get its name? You could use a cappuccino right now. I'll give you a hint. It's an Italian one. You don't know?
It's not, and I can guess.
Guess.
Because it has the cream on top and it's like a hint.
Isn't it just like, isn't that the simplest?
What does cappuccino mean in Italian? You don't
Just
know?
use it for the color.
It's like type of lunch.
The drink's name, which means little cat in Italian, little hat,
Yeah.
okay, was inspired by the 16th century Capuchin monks. Capuchin monks.
Yeah,
Okay, who wore distinctive brown hoods that were the same color as a cappuccino.
Yeah.
How about that? Capuchin, how do you say that?
Cappuccino.
Capuchin. You say capuchin, I say capuchin. You say,
So is this?
you say,
Oh my god.
oh my God. Why can't this teacher ever be serious? I don't know. I don't know. Okay, let's move on, okay, shall we? All right, so, I don't know. Okay. Okay, you ready for the next thing? Okay. Oh, sorry. I didn't even see that. Okay, so here's where it gets tricky, and this is where it gets fun. Analyze the graph of this polar equation. So the first thing I'm going to do with this one is, this one gets kind of cluttered. I got to warn you, okay? So what would you think be my first step for this one? Divide everything by 3, okay? Divide this by 3, divide this by 3, divide this by 3. Now I get R equals 32 thirds. This is really not that bad if you just kind of follow on with me. 5 thirds sine theta, okay? Is this a, what shape is this? Based on this, what shape is this? Right, because E is bigger than 1. If that was 1, then it would be a parabola. If that was less than 1, it would be an ellipse. Since this is bigger than 1, this means it's a hyperbola. Hyperbola. Now I'm just going to draw a quick little sketch. Its sine, its plus, is my directrix above or below the polar axis, and is it parallel or perpendicular to the polar axis? Parallel. Is it above or below?
Above.
Above. Okay? So my directrix is somewhere over here. If I want to find exactly where that directrix is, okay, this number up here, 32 thirds, that's EP. Remember from EP over 1 plus E sine theta, right? So I don't want to. So this is EP. We know that E, right? This is E. E is equal to 5 thirds. E equals 5 thirds, okay? And so you know that 32 over 3 is equal to 5 thirds times P. So what's P equal to? Can anyone do that right? 32 over 5, okay? I could just multiply through by the reciprocal. I would get 32 over 5. So in XY coordinates, this is Y equals 32 over 5 in rectangular form. You get that? That's where my directrix is. Now, with all of these, whether it's a hyperbola, ellipse, or parabola, you always have one focus at the pole. So I'm just going to sketch this. It's going to go like this over here, right? And then, where's the other branch going to be of this hyperbola? Above or below that one? No, it's got to be up here somewhere, right? Because hyperbolas, you couldn't have another branch down here, right? Or be an ellipse. So there's another point up here, and the other branch. So it's going to look something like that, okay? Now, when they say analyze, what they mean is find this point, find this point, find this point, find this point, find the asymptotes, find the foci, all that kind of stuff. That's what they mean by analyze. Okay? So the way you do that is by making a table. Okay? So you make a table over here, and you only really have to plug in 4 points. R, theta, I'm going to plug in theta is 0. Guess what else I'm going to plug in? Pi over 2. What else? Pi and one more. Because 2 pi is going to be the same as 0. What else? 3 pi over 2. That's all I have to plug in for theta. I would plug those into the original equation. So plug into original, because your math is easier. Okay? Original, which was, let's change colors, which was 32 over, just because the math is easier to do if you plug into the original rather than deal with fractions. 5 sine theta. Yes, Cassie?
Why are you plugging in 3 pi over 2?
Because that's going to give me either this point or this point. I'm not sure which one yet, but it's going to give me one of those 2 points. And same with this, pi over 2 and this, I'm not sure which is going to give me which, but one is going to give me one. So when I plug in 0, look at this equation. What's the sign of 0? What's the sign of 0? 0. So 3 plus 0 is 0. So out here I get 32 fifths. Oops, 32 over 3. Sorry, not 32 over 4. Right? Because 5 sine of 0 gives you 0, right? So you get 3 plus 0, which is 3. So I get 32 over 3. Questions about where that came from? Which point is that on this graph? Where's 32 over 3 comma 0?
It's the one on the right.
It's the one on the right, because it says, and I would label these points in rectangular form. So this is, in rectangular form, this is 32 comma 0, right? 32 comma 0, rectangular coordinates at that point. Hello? With me there? Okay? Let's find this point over here. I'm guessing that it's going to be this one, right? So if I plug in pi in here, what's the sign of pi? What's the sign of pi, Evan? Evan? What's the sign of pi? No, it's not. Evan? In your head, not with a calculator. It's 0. What's 3 plus 0? What's 3 plus 0? 3. So again, I get 32 over 3. Whoops, not 3 pi. 32 over 3 when I plug in pi. Okay? So here's this point, here's that point, here's this point. Okay? So that corresponds to go out 32 over 3, rotate through. What would this point be in rectangular form? Negative 32 comma 0. Do you guys, or negative 32 over 3 comma 0. Oh, I forgot the 3 down here too, didn't I? 32 over 3 comma 0, negative 32 3 over 0. Everyone with me? There? Now I'm going to plug in pi over 2. When I plug in pi, what's the sign of pi over 2? 1. 3 plus 5 is? 3 plus 5 is 8. 32 divided by 8 is 4. Okay, so if I plug in pi over 2, I get out 4. I think that this is this point right here. Okay? How do I know the difference? Because how do I know which is which point? How do I know which is which point? Well, this looks, well, let's figure out what the other point is. 3 pi over 2, if I plug in 3 pi over 2, I get, what's the sign of 3 pi over 2? Negative 1. 3 minus 5 makes negative 2. 32 divided by negative 2 is what? Negative 16. So negative 16, 3 pi over 2 is way, you understand that's further away, guys? So this point right here corresponds to this one, because I go back 16 and around 3 pi over 2. So in rectangular form, this would be 0, comma, 16. In rectangular form, this point here would be what? 0, comma, 4. Yeah?
It's like graph.
It's right. Just wait. What?
The graph that with my calculator. Yes, yes.
Well, you have to put on your axes. You got to go zoom, make a good window. It'll work. Okay?
You like the awesome.
Where's the center? Center. Who can tell me where the center is? If one vertex is here at 0, 16, right? This is 0, 16, and this is 0, 4. What's halfway between 16 and 4? 0, 10. So the center is going to be at 0, comma 10. Okay, and then to move on, okay, if we know where focus 1 is at 0, 0. Where's focus 2? Where's focus 2? That's this point up here. If the center is at 0, 10, okay, and this is at 0, 0, what's this point right here? How far? What is it? 0, 20, thank you. Okay. Everyone see why it's 0, 20? Because this focus is 10 away from here, so this focus has to be 10 away from here. So this point here is 0, 20. That's not on the graph, that's just the focus. Then I can do a squared plus b squared equals c squared. I know I'm rushing, okay, but I'm trying to get through this, okay. What's c? C is 10. That's the distance from the center to a focus. Center to a focus, C is 10. What's A? Center to a vertex. 0, 10 to 0, 16. What's A? 6. Okay? For a hyperbola, this relationship still works. A squared plus b squared equals c squared. So 100 equals 36 plus b squared. So b squared equals what? B squared equals 64. So b equals 8. And now I could write the equation of the asymptotes. Y equals k, plus or minus, in this case it's a over b. A over b m minus h. Okay? So in this case, what's k? What's k? No? K is 10. Okay? A we figured out over here is 6. B we figured out over here is 8. There is no horizontal shift of this center, so it's just x. And that's the equation of your two asymptotes. You can reduce that to 3/4. Okay? Equals 10 plus or minus 3/4 x. And then you found everything there is to it. That's what it means by analyze. Okay? Find the intercepts, find the vertices, find the asymptotes, find the directrix, find the foci. We did all that stuff. Okay? There's one more thing.
That like a year though.
What?
Probably took like
Yeah, those take a long time. You'll have one like that on your slides. Okay? Either like that or an ellipse. Okay. Last problem. I just want to set this up. I still have about 6 minutes or so, so just chill a minute. Okay. This one's pretty easy. The eccentricity of Mars is approximately 0.09 at its closest distance to the Sun. is approximately 128 million miles. The way, hey, I know I'm losing some of you, but I need to talk, okay? So, you call this the sun right here. And then you make an ellipse, okay? Where's my tool? This one makes an ellipse. Watch this. Where's my ellipse? Ooh, watch. If I start here, there's the sun, and here's Mars over here, okay? Here's Mars. And at its closest distance, okay, this distance is 128 million miles. But I'm not going to worry about that. I'm going to worry about that there's a directrix over here. So this is an equation of the form R equals EP 1 plus or minus cosine. Plus or minus. Plus E cosine theta. Okay? The way you do this, they tell you E, right? That's 0.09. And they tell you E up here is also 0.09. And then when theta is equal to 0, okay? When theta is equal to 0, R is what? 128 million. 128, 0, 0, 0, 0, 0, 0. So then what you could do, you could solve this equation, find out what P is, and then you could rewrite the equation with just EP on the top and theta, your variable being R and theta. So you just plug in this, and you plug in 0. You could solve for P, and then you rewrite the equation with the variables R and theta in there, okay? And you end up getting R equals, I don't know. Okay, okay. That's it. That's your homework.